Consider for a moment the Millau Viaduct, a structure 2,460 meters long, soaring 268 meters above the valley of the River Tarn. These are just figures, but just stop to think how much calculation goes into such a feat of engineering. In fact, it took the Grèche engineering office 80,000 hours, 2,000 drawings, 15 engineers and 20 draftsmen to design the Millau Viaduct. And as incredible as it now may seem, the Millau Viaduct has not always been there. Not long ago, the road between the Red Course and the Course of Larzac was constantly clogged with mile after mile of traffic jams. Of course, now and again, tentative ideas would arise, but was it really possible to put a multiple cable-stayed viaduct across the valley? Initially, the idea of using steel had attracted the minds of the engineers, but most thought that a viaduct made entirely of concrete was the solution. But then the agency that promotes the use of steel in industry asked Grèche to optimize the metal option and to come up with a competing design. At the start of the year 2000, Grèche put forward the draft design for a viaduct using steel in preference to concrete, the positioning of the deck by the launching technique. This was a pioneering and really daring idea which would involve building some of the biggest temporary piers in the world. As the engineers opted for the push deck system, it also meant they would have to build the longest push deck system in the world. Only FL Construction Métallique had the confidence to take up the challenge, and they pulled it off. The Eiffage Group was given only 6 extra months of design work to complete their proposal for the competition. Talk about tight deadlines. Grèche took advantage of this time to optimize the technical choices, the construction methods and the completion deadlines. It was based on this revised project that the contract was awarded. In the first half of 2001, even before the contract was signed, the Eiffage Group asked Grèche to begin the implementation studies. The first task was to make all the calculations for the viaduct in operation: foundations, piers, columns, decks, pylons and stays. Grèche set about the necessary optimization and redimensioning work. In particular, it carried out preliminary wind tunnel tests to analyze the effects of wind on this huge structure. To make the necessary calculations for a potential wind speed of 225 kilometers per hour, Grèche had to write a series of new software applications. For Grèche, the most important engineering work lay ahead, especially the launch studies. Would it be possible to move on a 3% slope a 2-part deck of which one of the parts is 1,750 meters long? To answer the question, not only did Grèche have to calculate each push cycle and assembly configuration and analyze every imaginable accidental stop configuration, but it also had to design and develop the necessary mechanism and tools to assemble and push the deck. Grèche set to work. With the University of Liège, it developed the special calculation rules required for this type of deck. The resulting design not only complied with the French and European standards in force, but it exceeded them. Grèche developed a series of pioneering processes. Temporary piers. This effectively reduced to 171 meters the distance to be covered by each launch. Joists. This idea made it possible to duplicate longitudinally the launch supports for each pier, allowing the engineers to launch a caisson 4 meters 20 high over a distance of 171 meters. Balancing devices. These were designed to prevent the 2 supports for the piers and the temporary piers from undergoing asymmetrical loads as the sections of deck advanced. Finally, the load displacement systems, the translators. These allow the piers and the temporary piers to withstand the tremendous friction generated by the movement of the deck. In short, there was not one construction problem for which Grèche did not come up with a viable solution. Grèche had been given the task of making all the engineering drawings for the metallic elements of the viaduct and for the elements required for its construction, but in addition it provided much needed assistance on the construction site. In preparation for each launch, Gresh analysed the meteorological data 1 week before the start of the operation. During this time, 4 Gresh engineers were on site to assist the construction site managers to analyse and control the behaviour of the viaduct and to take immediate action if required. At the same time, a team of engineers was on standby in Liège to make any necessary critical calculations. The viaduct took shape as the construction work went ahead, 171 metres at a time, as huge sections of deck were launched until the last section was in place and the final gap was closed, confirming no fewer than 18 times the calculations and designs conceived by Gresh, until the 28th of May 2004, when the viaduct itself unleashed the champagne. To guarantee that every section of deck was perfectly in place, Gresh's team of devoted men and women were on hand at every major stage in the construction of the viaduct. It was, of course, a race against time from the very first day, but when it came to transporting the pylons, the rush was on in earnest. It took no fewer than 4 60-wheeler juggernauts to transport these 850-ton pylons to the erection site. Furthermore, this called for systematic verification of each section of the deck and the reinforcement of the deck where it crossed the temporary piers. The laying of the deck on its definitive supports called for the development of a very special process. The positioning of the stays was carried out according to a process that Gresh had already used for many cable-stayed bridges. Thanks to constant interaction with the construction site, the geometry went perfectly according to theory. There was one more crucial detail, the coating, which was applied in one single 2,640-metre pass. But would the deck withstand the thermal shock? This was followed by checks and more checks. No problem. Then a final test for the road. The viaduct was crossed by no fewer than 30 heavy trucks with a total mass of 900 tons. Result, the viaduct didn't bat an eyelid, even with a 60-centimetre deflection. Of course, this was no surprise, since Gresh had designed the viaduct to carry twice as much weight. Since the 14th of December 2004, every passing day has brought proof that the viaduct is behaving